The following is a discussion of the 7/10 H rule that is used to place a geometric constraint on the potential failure surfaces that are analyzed for a T-wall. Based on field observations and physical and numerical modeling, the Corps of Engineers has determined first that all potential failure surfaces should have a horizontal sliding block at or near the zone of the piles, and that sliding block should extend horizontally beyond the zone of the piles to the location of the critical passive wedge, and that the minimum width of the sliding block should be based on the height of the daylight location above the sliding block. This figure demonstrates the geometry that's used in determining the 7/10 H rule. We've identified the width of the foundation of the T-wall with W and the height of the daylight location above the critical slide plane with H. And essentially the 7/10 H rule is either W, the minimum width of the footing, or 7/10 H above the slide plane. Active wedges are drawn from the location of the slide plane at the heel of the retaining wall and are drawn at an angle of 45 plus phi over 2, and the daylight elevation is identified, and then the height is determined, and 7/10 of that height is then added to the x-coordinate at the heel of the T-wall to determine the minimum x passive position, or the minimum x position for the passive wedge. We've also depicted on this drawing piling that would be driven beneath the T-walls into the Pleistocene deposits in the New Orleans area. The 7/10 H rule is used in the same manner for both Spencer's and method of planes evaluations. In other words, we only have to determine it once for a given T-wall geometry and for given soil properties and a failure direction. Hence, for a typical T-wall evaluation, there will be 4 7/10 H rule determinations. The first one would be for the top of wall and the still water level for both Spencer's and method of planes analyses. The next one would be for the low water Q case for both Spencer's and method of planes. The next one would be for the low water S case for a failure on the protected side for a Spencer's analysis, and the final one would be a low water S case for a failure on the flood side for a Spencer's evaluation. Here is an example of the 7/10 H rule applied to an actual problem. The first thing that we do is we draw a vertical line at the heel of the T-wall. The T-wall is located in this position. The vertical line is drawn, and then for each one of the analytical depths that we're going to consider, an active wedge is drawn in using the 45 plus phi over 2 rule. In this particular case, all of the soil layers are cohesive layers, and hence there is no friction, and all of the angles are drawn at 45 degrees. We then look at the daylight elevations and the corresponding height for each one of the particular slide planes, and we look at the minimum width of the base of the footing, and we draw the larger of the two, so that we have an upper zone here where the minimum slide plane is the width of the footing, and then after we get below elevation minus 10 in this particular instance, then the minimum passive wedges begin to increase. It's also interesting to note that the critical passive wedge locations that have been drawn in to the right of the minimum passive location do not correspond with that minimum passive location. In some cases, this is what happens for our analyses.